We've been talking about some ways in which plants and animals deal with changes in their environment. And today we'll continue that discussion by looking at dormancy. First, we'll cover what dormancy is and why organisms become dormant. Dormancy is a state of inactivity that organisms or living things enter when they need to conserve the resources available to them and reduce their demands on their environment. Most major groups of plants and animals have some representatives that can become dormant. So what is the value of dormancy? To start with, animals that have the ability to become dormant can survive conditions which are stressful in environmental terms. For instance, when lakes, ponds, or rivers dry up, aquatic organisms that have the ability to enter dormancy can survive the drought, while others that cannot do this will die. Another advantage is that creatures that can become dormant in very inhospitable conditions, such as extreme cold, can live in a larger range of places than other organisms. And because of this, because they can live in places where other animals can't survive, when they are actually active and looking for food, the amount of competition they have to deal with from other creatures is greatly reduced. Let's move on to look at what causes dormancy. There are a number of variables, but the ones that are the most significant are changes in temperature and the amount of light organisms get. Availability of food, water, and oxygen is also very important. Now we'll explore some specific examples. Let us first look at dormancy in insects. Insects can experience a reduction in their metabolism, which is a form of dormancy called diapause. In insects, diapause is either a reaction to difficult environmental conditions or a necessary part of the life cycle, such as with butterflies or certain moths. In terms of environment, it's interesting to note that through dormancy, insects can survive when it's very cold. Another creature we'll look at is fish. Fish share the same main environmental causes for dormancy as other creatures. But as one might imagine, they are particularly sensitive to drought. Let's take the African lungfish as an example. When the water supply is low, the African lungfish burrows deep into the mud. It surrounds itself with a cocoon of slime and remains inactive. While dormant, it faces two dangers. One is the possibility of starvation, and to overcome this, it relies on fat it has stored up in its body. The other is desiccation, or drying up, which is addressed through a reduction in the production of urine. Snails are also known to become dormant. Some snails seal off their shell with a membrane of dried mucus after settling at their place of dormancy. Other snails do not have this possibility. They trust the protection of their shell. Snails that remain outside during their dormancy can usually be recognized by a rather brightly colored shell, reflecting the sunlight and so minimizing evaporation. That is why in open habitats, banded snails usually have a yellow shell. Probably the most well-known type of dormancy is hibernation, which occurs in warm-blooded creatures during the winter. We know that warm-blooded animals maintain a regular body temperature. So what's really interesting about hibernators, true hibernators that is they can actually adapt to extreme conditions by turning off their internal thermostat, so to speak, and hibernating until conditions improve. Let's examine the behavior of a true hibernator, the Arctic ground squirrel. This squirrel digs underground and builds a nest that is insulated. Once in its nest, it curls up into a ball and tucks in its arms, legs, and tail. Its body temperature mirrors the cold of its surroundings. At this point, the squirrel barely breathes and doesn't react to stimulus in a normal way. During this period of hibernation, the squirrel loses nearly 40% of its weight. The process of awakening for the Arctic ground squirrel takes about 3 hours. When this happens, there is a rapid rise in the heartbeat and circulation is affected. The area around the heart warms more quickly than the rest of the animal. And despite the strain of hibernation, within 24 hours of coming out of it, the squirrel's body processes are basically normal.
That is the end of Section 4. You now have half a minute to check your answers.